Yes. Yeah. Good afternoon all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Yes, sir.
Thank you. So we had just a small demo session in the last week. So yes, just let us have a quick recap what we have discussed, right? So what is big data? Why Hadoop? Drawbacks with the current databases, Hadoop and Spark advantages, right? And Hadoop and Spark job market. So as part of this course, we'll be having both Hadoop and PySpark, Spark with Python implementation, right? Yes. So big data, you got like huge volumes of data, right? In TBs, higher than that, beyond the TBs, we have got petabytes, exabytes, and zettabytes of data. Yes. So 1 petabyte equal to 1024 TBs, right? Yes, 1 to 1024 TBs. So we have got many applications which are generating huge data. We have got many applications which are generating huge data like Facebook, Twitter, Google, YouTube, Flipkart, Amazon, all this they are generating data, right? In petabytes. Yes. Yes. Yeah, yeah. Mhm. 1 second, 1 second, just 1 second. Okay. So yes, in this part of this course, like PySpark and Hadoop, yes, both will be covered. So here we have what databases like Oracle, MySQL, DB2, SQL Server. They are meant for OLTP, online transactional processing. We have got Teradata, Netezza, Vertica. These are specialized databases used for data warehouse purposes, like online analytical processing, right? The banking sector and social media, like huge data is getting generated. So as a solution to all this, as a solution to all these storage level problems and processing, not only storing that huge data in petabytes and processing that huge data, right? We have a framework called Hadoop. Hadoop is meant for two things, for storage and processing. If you talk about any technology, they will do either for storage or for processing, but Hadoop performs both storage and processing. For storage, it doesn't use any database for storing its data because databases has got some drawbacks, right? Despite of the drawbacks, it is going with a file system called HDFS, Hadoop Distributed File System. For processing, we are going with an execution model called as MapReduce or Spark. We are not using any technology like Java, other technologies, right? Yes, it is using a MapReduce execution model and Spark. Combinedly, they can store and process huge data storage and huge data processing, right? Yes, and Hadoop is not for online applications. Hadoop is not meant for online, it is meant for batch applications. Hadoop is meant for batch applications. Batch applications, two types of applications, online and batch. Online means user gives the input, user interactive applications, booking a movie ticket or making an online transaction. Batch applications, user non-interactive applications. Here user is nowhere required. For example, PNR status, railway ticketing PNR status. Yes, your ticket status, right? Like currently 200, later it becomes 150, it becomes 150, and finally it gets confirmed. It happens in the background, right? Generating credit card statements for the millions of customers. No way, your user is nowhere required. So user doesn't give any input. Most of the financial applications, bank applications are batch applications, right? And drawbacks with the current databases. Why databases can't be used for storing Hadoop data? Because limited storage in databases in GBs or in TBs. Yes, no parallel processing, no parallel processing in most of the databases. If volume increasing, right, speed decreasing in the databases. Yes, for example, if you take these three queries, right, I want the total amount generated from this particular table sales one, total amount from sales two table, total amount from sales three. But in sales one, you got 10 records, in sales two, 1 lakh records, sales three, 1 crore records. Which query executes faster among these three means the first query, because total amount of 10 records only. So query to query, as volume increasing, speed decreases, right? The same way, if complexity increases, right, speed decreases in the case of databases. If you see the total amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? You see these three, right? Which query executes faster among this? Which query executes faster among this? Total amount or average amount or standard deviation of amount? Which query executes faster among this means first query, right? Total amount from sales one, because average is a two-step process. First submit it calculates, next it calculates average. So query to query, as complexity increasing, speed decreasing. 1 second. Okay, yes, sorry. So average is a two-step process as compared with the first one, second one taking more time, and standard deviation, lot of internal processing required as compared with the other queries. Query to query, complexity increasing, speed decreasing, right? And major drawback with databases, they can handle only structured data. Databases can handle only structured data, which is in the form of rows and columns. But today, if you see the data, huge data is getting generated. You see, like most of the data is of semi-structured or unstructured data. So we need to have proper tools for storing and processing it. So Hadoop framework is one of the best tool for storing and processing this semi-structured and structured kind of data. So, and Hadoop is not for, Hadoop doesn't follow client server web architecture while client giving the request, getting the response, not like request response architecture. It follows master slave architecture, single master, multiple slaves, single master and multiple slaves. Observe this, yes. Single master and multiple slaves. S1, S2, so on up to Sn, right? Single master and slaves. Master and slaves architecture. Slaves, master node, or we call it as name node. Slave node or data node, we say, like data node. So if we take, if in Hadoop, data is stored in the form of files. The file data is divided into smaller parts. This is a huge file, TBs of data divided into smaller parts, and this each part stored across multiple systems. Means data is distributed. Two advantages: distributed storage and a parallel processing, right? Yes, because of this data, this file is going to be accommodated by this, and the fast execution, right? Hence you can see, because of parallel processing, you can see high speed. Two advantages. So data stored by the slaves, data processed by the slaves. Then everything done by the slaves. What the master node will do means, who assigns the task to the slaves? Master. Who balances the load? Master. Fault tolerance means if any one system or slave means what? System. So group of systems connected in a network. So if any system goes down, then the task of it will be assigned to any of the other available slave or system. That's what we call like fault tolerance. Health monitoring. Health monitoring, right? So before assigning the task to the slaves, which will master node will have the health status of each and every system, slave system. Slave node responsibility, storing the data and processing the data. Yes. Advantages of Hadoop as compared with the databases. Unlimited data storage because of horizontally unlimited scalability. Unlimited scalability means unlimited number of slaves can be added. Horizontally means today you have got 10 slaves. Tomorrow your business has increased. If your data is increased, customers are increased, right? You will be increasing the number of slaves horizontally. 10 to 100, 100 to 1000, 1000 to 1 lakh, right? So in this way, the number of slaves keeps on increasing. Very high speed processing because of parallel processing. Data is distributed all across multiple systems, processed by multiple systems parallelly. Means work done by single person, work done by multiple persons. There is a difference, high rate of speed, right? For the people who are working parallelly. The same way here systems, right? Work done by a single systems, work done by multiple systems, right? Because of parallel processing, very high speed. Can handle all varieties of data, structured, semi-structured, and unstructured. Hadoop can handle all varieties of data. Open source, no licensing required. This is an open source. And commodity hardware. Commodity hardware means it can run on any hardware. Doesn't mean that you need to have highly configured hardwares. No. So Yahoo has conducted a test to check the speed of these various databases by taking 100 TB data, sorting based on 16 columns. Sorting based on 16 columns. Oracle has taken 3.5 days to process it. MySQL has taken 6 days. Teradata has taken 4 or 4.5 hours. Right. Netija has taken 3 hours. Hadoop has just taken 3.4 minutes, where the other things taken days and hours. Hadoop has taken 3.4 minutes. And latest version of Hadoop just 1.2 minutes per day. Why databases like Oracle doesn't support unlimited storage? Yes, this is what the speed of Hadoop, right? As compared with other things, very high speed, right? Very high speed. So that is Hadoop is proven in the market processing point of view with a very high rate of speed as compared. So today, like most of these projects are migrating towards this Hadoop and Spark environment because of the very high rate of speed. Yes. And there are questions like why databases like Oracle cannot support unlimited storage. Databases, right? Yes. They have got limit on the number of slaves like Oracle, MySQL, MySQL Express, DB2, all this they can support up to 256 slaves. Yes, you know ready, right? The whatever I'm saying, right? Okay. Yeah. Yes, PySpark only in this course, right? PySpark only will be covered in this course, right? Not Spark. Not Spark means Spark with Scala. Yes, PySpark only as part of this course. Spark with Python implementation only, right? Yes. Srinu Reddy. Yes. Yeah. SQL like 256 slaves, right? Yes. So all this, right? They have got 256 slaves, but beyond that, they cannot support. But specialized databases which are used for data warehouse purpose, right? Teradata, Netezza, Vertica, they can go with 512 slave systems. Currently, they are going with 1024 systems, 1024 slaves, right? Yes. Okay. But there is no, so there is a limit on the databases, right? 256 or 512 or 1024. There is no limit on the number of slaves that Hadoop can have, right? There is no limit on the number of slaves. Slaves means systems. Systems. One master, one slave. It can go with unlimited number of slaves, systems, CPUs. Slaves indicates CPUs. There is no limit on the number of systems or slaves that Hadoop can have. It can go with unlimited number of slaves. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with 12,000. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, Facebook going with 42,000 slaves, right? 42,000 slaves. Hadoop ecosystem components. Hadoop ecosystem components, right? For storing and processing, storage and processing. HDFS meant for storage. MapReduce meant for processing. Yes, we have what are the components I'm going to discuss as part of this, right? Apache Hive. It is a data warehouse kind of environment in the Hadoop framework. It is using a language called HQL, which is almost similar to SQL. Scoop for importing or exporting data. How to import data from databases to Hadoop and how to export data from Hadoop to databases. NoSQL, schema-less behavior and random access. NoSQL database. In the coming days, we see more implementation of this NoSQL databases. So I'll be discussing one NoSQL database, HBase. Yarn, yet another resource negotiator. So the Yarn architecture, Yarn components, Yarn processing, everything I'll be discussing in brief. Zookeeper, controls and coordinates all the other components, right? So for establishing connections, other things, right? The Zookeeper, right? Flume Kafka. Flume Kafka, right? These are used for streaming data, streaming technologies. So I'm going to cover this Kafka, Flume Kafka also, right? I mean, streaming technologies for live streaming data, capturing live streaming data. Streaming data means data which keeps on generating, which keeps on incrementing. And PySpark, the main component, right? PySpark here. So in that PySpark, right? PySpark core programming, PySpark SQL, right? So here, right? If you feel Spark means by default it is Scala implementation. So PySpark SQL, PySpark streaming, this everything will be covered in brief, right? Yes. So I was just saying you, right? So you'll be given the software and total Linux commands required for this will be discussed and find these things. So there are two packages here for Hadoop, PySpark, and Linux. So 12K and ones like Hadoop, PySpark, Linux, and Python, right? It's 15K. So this which package, right? If you have got knowledge on Python, just go with this. If you doesn't have knowledge on Python, yes. Python separate sessions will be there, such separate classes will be conducted, right? For Python, yes. And this everything as part of this course. Okay. How exactly the data storage and processing is going to happen? how exactly the data is stored. How exactly the data is stored in Hadoop. In Hadoop, data is stored, right? Data is stored in the form of files. Data is stored in the form of files. Each file is again subdivided. Each file is again subdivided into blocks. Default block size. Each file is again subdivided into blocks. Default block size. Right? Okay. 64 MB, yes. And in latest versions, it's 128 MB. It is 128 MB. Okay. Each file is subdivided into blocks. Default blocks are 64, and in latest version, it is 128 MB. Okay. For example, how this data is stored in Hadoop. I'm taking a file f1.txt. I'm taking a file f1.txt. The size of this file 200 MB. Assume that 200 MB. Let me say default block size. Default block size equal to 64 MB. Assume default block size 64 MB. Into how many blocks the file is divided? Number of blocks. Number of blocks equal to file size by default block size. File size by default block size. Number of blocks equal to file size by default block size. File size, right? Yes. (200 MB). By default block size 64 MB, right? What is that approximately? How many blocks? 4 blocks. Approximately 4 blocks. B1, B2, B3, and B4. How many blocks? 4 blocks. B1, B2, B3, and B4. B1 64 MB size. B2 64 MB. B3 64 MB. B4 only 8 MB, right? Is that 20 divided by 64? Yes. This B1 stored in system 1. Slave 1. Slave means system. System 1, this one, and system 2. They are distributed across the multiple systems, right? System 3, system 4. Yes. Just you need to provide the block size. Everything will be loaded in automated fashion. Right. So this is how the data is stored. But I got a file f2.txt. Think this f1.txt is some data related to telecom, right? And the f2.txt, observe this f2.txt, size 192 MB. 192 MB. It's a data f2.txt 192 MB. Banking data. Banking data, right? Its data is what? Banking data. Its what data is what? Telecom data. Retrieving, okay, f2.txt size 192 MB means number of block. Yes. The same thing I'm copying right there. File size by default block size 192 by 64. 192 by 64, exactly 3 blocks. Exactly 3 blocks. I'll take it as B5, B6, B7. B5 64 MB, B5 64 MB, B6 64 MB, B7 also 64 MB. Exactly what these are stored in S5, S6, S7, system 5, system 6, system 7. Yes, number of blocks. Here retrieving f1.txt. Here 56 MB free. Here 56 MB free. Observe here 56 MB free in this B4. So here I got a query. Why B4? Why B5 data? Why B5 data is not stored in B4? Why B5 data is not stored in B4? Why B5 data is not stored in B4 when 56 MB is free? When 56 MB is free. Try to check. Even though 56 MB is free, why this B5 data is not stored in B4? Assume it is stored. Retrieving f1.txt. f1.txt. Retrieving f1.txt means b1 plus b2 plus b3 plus b4. b1, b2, b3, b4. b1. Assume if b5 stored in B4, then so 64, B2 also 64, B3 also 64, and B4 8 MB 8 plus 56 of total. How much? What is the total? 256 MB equal to 256 MB. But the actual file size, right? 200 MB. But the actual file size is 200 MB. So 56 MB data extra you got, right? So here when we are retrieving telecom data, but you got some banking data, which is a wrong computation, right? Which is a wrong computation. Here we got a part of when we are retrieving telecom data. When we are retrieving telecom data, right? f1.txt. We got a part of banking data. We got a part of banking data. So every file will have dedicated number of blocks. So every file will have dedicated number of blocks. So here this I can include some. The first point, this one I'll take it as a first point. Design principles. Design principles with respect to every file will have dedicated number of blocks. Each block is associated with only one file, or it can be overridden by administrator. So in HDFS, there is no kind of overriding, right? We cannot overwrite, we cannot modify the data, right? Here, every file will have dedicated number of blocks. Every file f1.txt has got 4 blocks. f2.txt has got 4 blocks. I'm talking about blocks, dedicated number of blocks. Yes. So here, every file will have dedicated number of blocks. In a single block, no 2 files data to be stored. No 2 files data to be stored. In a single block, no 2 files data to be stored. No, 2 files data cannot be stored, right? Yes. Next, all the blocks will have all the blocks equal volume. All the blocks will have equal volume except the last block. All the blocks will have equal volume except the last block. Observe this. Equal volume except the last block means the 64, 64, 64, only the last block except the last block will have different. So these are design principles with respect to it. Okay. Configuring block size. Configuring block size. Configuring means increase or decrease. Configuring block size. Increase or decrease of block size. So by default, it will be 64, 128. Even we can have our own block size. So for that, go to Hadoop install folder. Go to Hadoop install folder, right? Within this, there will be like conf folder. Within the conf folder, hdfs-site.xml. We see this file hdfs-site.xml within the Hadoop install folder, conf folder. hdfs-site.xml. Open this file and open this file and configure the block size. See, hdfn-site.xml. Okay, so we in configuration XML, right? XML files will be like configuration/configuration, right? Yes. Configuration/configuration. And here property, yes. /property. Property name and value. Property name. DFS dot block size. DFS dot property name it is. DFS dot property, the block size name. So by default, you can have our own block size 50 MB, 50 M. Property/property name DFS dot block size value 50 MB, right? It's /value. Okay. So this is how to configure the block size. By default, block size will be 128 or 64, right? So if we can configure our own block size. Yeah. Yes. Now observe, I'm going to discuss how data storage and processing. Data storage and processing. Data storage and processing, right? Yes. Observe this, right? Case one, I'll discuss some 3 cases here. Case one, right? Number of blocks, number of blocks number of slaves. Number of blocks equal to number of slaves means systems. then full parallelism is C. Number of blocks, for example, four blocks, three blocks, three slaves, B1, B2, and B3, S1, S2, and S3. Yes, I got f1.txt, f1.txt, yes, f1.txt of 192 MB. Default block size equal to 64 MB. Into how many blocks it is divided? Number of blocks. (192 by 64). Exactly like three blocks. Three blocks means B1, B2, and B3. Yes, how these blocks are stored across, right? This is the master, these are multiple slaves. Slave 1, slave 2, slave 3. Three slaves, S1, S2, S3, right? How many blocks? Three blocks. B1 stored here, B2 stored here, B3 stored here, right? This master node, which consists of name node, stores metadata, right? Stores metadata. So this f1.txt divided into how many blocks? B1, B2, and B3. B1 stored in system 1, B2 in system 2, B3 in system 3. Fine. This data storage, right? How exactly the data stored in? Now data processing. In Hadoop. Number of tasks in Hadoop, number of tasks always depends on number of unique blocks. Number of tasks equal to number of unique blocks. Okay, number of tasks always depends on number of unique blocks. How many blocks? How many blocks here? 3, right? 3 means tasks also 3. T1, T2, and T3. Okay. Job divided into 3 tasks. T1, T2, T3. T1 for executing, T2 for executing B2, T3 for executing B3. Block 1. Think that in B1 10 lakh records, in B2 10 lakh, in B3 10 lakh records. 10 lakh, 10 lakh, 10 lakh. So T1 task is nothing but executing this B1 10 lakh records. T2 is for executing B2 10 lakh records. Okay. Who should execute this T1 task? Which system? Which system has to execute this T1 task?
Yes, sir. Play one.
S1 only, right? S1 only, right? Why? Because B1 is present in S1. So S1 only can execute this T1 task. There's no other choice because B1 is present in S1. S1 only should execute this. Sorry, S1 only should execute this T1, right? Who should execute this T2 task?
Yes, two.
S2. There's no other choice. And who should execute this T3 task?
Yes, three.
S3. So here, what is your observation? Here, three slaves, S1, S2, S3. Here, three slaves, S1, S2, S3 are executing three tasks, executing three tasks, T1, T2, and T3 parallelly. They're executed parallelly, right? All the three tasks are executed on three systems parallelly. Full parallelism. Full parallelism. No task is in the waiting state, right? No task is in the waiting state. Any query in this anywhere? Hello? How this data storage and data processing in Hadoop always the number of tasks depends on number of unique blocks. Okay. So full parallelism, very high speed you are going to see when you have got the number of blocks and number of slaves are equal. Now case 2 you observe. Case 2 you observe and say me, right? Yes. Number of blocks greater than number of slaves. Number of blocks 4. Number of slaves 2. Number of breaks greater than number of slaves means if 4 blocks, 2 slaves. 4 blocks means like B1, B2, B3, B4. Slaves like S1, S2. 2 slaves S1 and S2. F1.txt. Think that F1.txt 230 MB. Default block size 64 MB. Into how many blocks it is divided? Number of blocks. Number of blocks equal to 230 by 64 means how many blocks? 4 blocks. 4 blocks B1, B2, B3 and B4. B1, B2, B3 and B4. How these 4 blocks are stored across this? Only 2 slaves, right? S1, S2. S1, S2. Only 2 slaves. B1 here, B2 here, B3 here, B4 here. This data storage, right? More blocks, less slaves. Now, data processing. So here f1.txt. Divide into how many blocks? F1 dot txt divided into how many blocks? B1, B2, B3, B4. B1 in S1, B2 in S2, B3 in S1, B4 in S2, right? S1, S2, S1, S2, right? Yes. Now, data processing. Number of tasks equal to number of unique blocks. How many unique blocks here? 4 blocks. Why I'm saying the word unique, I'll say 4 blocks. Sorry. 4 blocks. 4 blocks means 4 tasks. T1, T2, T3, T4. To execute these 4 blocks, right? We require 4 tasks. T1, T2, T3, T4. Who should execute this T1 task?
Yes, one.
S1. T2 task.
Yes, 3.
Where is S3?
Yes, two.
S2, right? T2 by S2. T3 means B3. B3 by again S1. T4 means for executing B4. T4 is for executing B4.
Sir, 4 are not
Yes,
unique
two.
blocks, right?
S1, S2, S1, S2. They are not unique. They are different blocks. 4 different blocks. Now here, as I understood your query, so here, say S1 is there, S2 is there. How many tasks S1 is executing? How many
Two.
blocks?
Two
S1,
tasks.
S1, B1 and B3. S2, B2 and B4. Who is executing this B1? S1. B3,
Yes.
B2 by whom? S2. Sorry. B1, B3 both by S1. B2 by S2, B4 by S2. So here B1 and B3 both, when B1 is executing, B3 will be waiting. B3 will be waiting. Here, when B2 is executing, B4 will be waiting. So here, when T1, so B1 executing, S1 executing T1 task, sorry, T1 task and S1 executing T3. Here B2, T2 and T4. Who is executing that? T1 is executing, then T2 task will be in the waiting state. Here B2, T2, sorry, T2 executing, T4 will be in the waiting state. Means here S1 executing 2 tasks, S2 also executing 2 tasks. Means once T1 is executing, T2 will be in the waiting. When T2 is executing, T4 will be in the waiting state. Okay. Means here 2 tasks are only executing parallelly. Remaining 2 are in waiting state. Remaining 2 are in the waiting state, right? Yes. Only 2 are in executing, right? Remaining 2. Once the 2 tasks completed, next they will execute the next 2, which are in the waiting state. Means not full parallelism. No full parallelism here. Yes. So here less parallelism. less parallelism, right? Yes. Less speed, less parallelism, less speed. Because some tasks are in the waiting state. But observe this case 3. Observe this case 3, right? More blocks, only one slave. More blocks means B1, B2, B3, B4. Only one slave, S1. This is your master. This is your slave. F1.txt is divided into 4 blocks. B1, B2, B3, B4. All this stored on in S1, 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 S1. So B1, B2, B3, B4. B1 stored in S1, B2 stored in S1, B3 stored in S1. Sorry, not in the master, in the slave. B1 here, B2 here, B3 here, B4 here. This is the master node. The master node. All this B1, B2, B3, B4, everything stored by S1 only. Data processing, right? Data processing. Data processing, yes. Number of tasks equal to number of unique blocks. Number of unique blocks. Number of tasks equal number of unique blocks. How many unique blocks? 4. Means 4 tasks. T1, T2, T3, T4. Who should execute all these 4? S1 only. Sequentially, one after the other. No parallel processing here, right? So very less speed. Very less speed. What is your observation based on these 3 cases? If more slaves, more systems, high speed. If less slaves, less speed. If only one system, only one slave, very less speed, right? Yes. Any query in this 3 cases, everyone?
Sir, when you will get non-unique blocks, I mean duplicate blocks?
Yes. So I'm coming to that. So I'm coming back to the case. I'm coming to this case 1, right? Case 1. I'm coming to this case 1. T1 task by S1, T2 task by S2, T3 task by S3. 3 tasks are executed by the 3 slaves parallelly. Suddenly, if any one system goes down, right, then the task of it will be assigned to any of the other slave. Means here two things, right? 2 things you observe. Whenever the particular slave S2 is down, data is lost, 10 lakh records, right? 10 lakh records in this B2 block, 10 lakh records. If it is very sensitive data like banking data, it's a huge loss. If it is insensitive data, then okay. But here 10 lakhs records are lost and the task also is going to be failed. Yes. So how Hadoop is able to overcome this kind of situation, right? How Hadoop is able to overcome this kind of situation using a concept called replication and fault tolerance, right? Yes. Replication and fault tolerance in, what do you mean replication is duplication, and fault tolerance that I'll be discussing, right, in brief, in depth. Okay. Replication or duplication in Hadoop. Replication or fault tolerance. How we can solve this? By using replication and fault tolerance. What do you mean by replication? What do you mean by fault tolerance? The fault tolerance model and the replication, everything I'll discuss means we'll have replications, means same block repeats for multiple times. If any one system down also, still we have what other duplicated block, there won't be any data loss. Okay. I just have given you that, right? I'll be showing you all these things, right? Practically. So as part of this course, right? Someone was asking. So big data Hadoop, HDFS component in brief, Hadoop distributed file system. And apart from this, like scoop import and export operations, and yarn architecture, yarn components, yarn processing, NoSQL databases, and HBase, HBase, right? And Hive, very important component. Hive, lot of discussions on this Hive, right? Working with different types like XML, JSON, URL, weblog. Yes. Now coming to PySpark in brief, PySpark, Apache PySpark, PySpark Spark context, Spark session, parallelize, repartition, broadcast variables, accumulators, PySpark RTD computation, right? RTD computation, steps in RTD computation, RTD persistence, persistence features, persistence options, memory only, memory underscore SCR only, disk and SCR only, right? Memory and disk only, PySpark core computing. Yes, different ways of creating RTD, creating Spark objects, aggregations, groupings and aggregations, single grouping, multi-grouping, multiple aggregations, various inbuilt actions and transformations of PySpark. So these are all the inbuilt actions and transformations of PySpark. One by one in brief with many working examples. PySpark SQL data frame. Yes, many data frame APIs like creating of RTD from data frame, convert data frame to pandas, PySpark show, struct type, row class, column, select, collect with column. Yes, with column renamed where filter, right? Where filter, drop duplicates, group by, join, UDF, map, flat map for each sample, fill in a pivot, partition by array type, map type. PySpark SQL functions in brief, right? Aggregate functions, window functions, date and timestamp functions, JSON functions, built-in functions of PySpark one by one in brief. All these one by one functions of PySpark in brief. And external sources, integrations, MySQL, Hive integrations, transformations, and actions, handling nulls, right? Deployment mode, PySpark application, and yes. And those who go for, okay, I said, right, who wants Python also, in brief, Python core and advanced will be discussed. This Python operations, operators, IDs, working with different IDs of Python, flow controls, strings, collections, lists, tuples, sets, dictionaries, collections in Python, functions, modular programming, packages, errors, exception, file handling, object-oriented programming concepts, regular expressions, database access, Python datetime, OS module, advanced concepts, GUI programming, Excel workbook, data analytics, connection to data science, Python pandas, Python numpy, Python matplotlib, right? So this is for plottings and visualizations, matplotlib module, some data science and big data related modules, NumPy numerical Python, Pandas model, big data module, right? Detection data analytics. So this is going to be covered as part of Python. So for Python, right? So you can attend the batches. So for it's a weekend batch, right? This Hadoop, big data, Hadoop and PySpark. And for Python, right, multiple batches in weekdays will be going on. You can attend any of my batch. So day after tomorrow means on Tuesday at 8 p.m. in the evening, there is a batch going to start for Python where you can attend it. If it's not flexible, other timings also available. But for Hadoop and PySpark, this will be that regular timing. Yes. So in brief, in depth, we'll be discussing about Hadoop and PySpark, right? And also Linux, everything we're going to discuss on Linux environment. Okay. So yes, tomorrow we'll be going with that actual, right? We'll be entering into, I'll be discussing the Hadoop architecture, Hadoop storage architecture and processing architecture, right? And this fault tolerance, these things I'll be discussing, right? Yes. So you need to get enrolled, right? For tomorrow's session. Tomorrow's session, you need to get enrolled. So the link will be changing for tomorrow's session. Those who have got enrolled, see 4 offerings from my side. Yes. As a everyday session recording you'll be getting, right? Recorded video you'll be getting, right? Every day to your Google Drive. Notes, class notes, whatever we discussed, right? Everything the soft copy. And tasks, assignments and tasks to work with. And WhatsApp group for technical discussion, right? Yes. So these things. So tomorrow the link will be changing, a new link, right? That will be forwarded to your Gmail, to your mail IDs, to your mails, and check that if you are done with that. If you are done, so you can see a big message, right, in the chart. A big message in the chart about the course contents are forwarded, course content links are given. Yes. Payment process and procedure is given in that. Those who want with Python, it is 15,000. Without Python, it is 12,000, right? Right. And the contact details of the online team. And you can see if you're done with the payment, don't forget to send the screenshot of your payment to DURGASOFT online training to the same mail ID. They'll be forwarding you the link of tomorrow's class, right? So tomorrow I'll go with the architecture, Hadoop storage and processing architecture. So we have seen PySpark SLA has got great boom in today's market, very high speed processing, right? Any other queries, anyone?
Sir, I have a query. So for Hadoop, we also have Cloudera and Hortonworks.
Yes.
Correct. So will we be working on any proprietary software or is it going to be Apache Hadoop as a whole?
Apache Hadoop, and I'll also show you on Cloudera, right?
Okay, all right, sir. And any specific reference books which
Yeah,
you would like to recommend?
Yeah, I'll be forwarding you. Yes.
All right, sir. Thank you.
Fine. So tomorrow, same time at 4 o'clock, but with different link. So get enrolled. So once you got enrolled, tomorrow a WhatsApp group will be created. You will be getting the videos to your Google Drive from tomorrow. Notes also will be getting, and software also I'll be providing in the tomorrow session. Software and VMware, and also especially like PySpark, I'll be showing you different environments, how to execute in Anaconda distributions, Jupyter notebooks, Spider IDs, different IDs, right, where we can run those things. Fine. So I'm signing off for now. Meet you tomorrow, right? Yes. Thank you all for your time. Yes.